Which of these tests is not true? There you go. There's proof of doing a question after I said, read the question and go for it. I've just answered it as which one is true. It gives an indication of ductility. And if I had read it properly, hands up, I got that one wrong. Here you go. Come on, James. Pay attention. Hey, everyone. We're back in the office, and we are going to have a look at another ProProfs quiz. It seemed to go down quite well every time we've done one of these. So I've found another one we can go through. I haven't looked at it yet. So we'll do it live together as we go through it. And hopefully we'll see if we can find some good questions to revise off. So here we are on ProProfs. I have found this one. So this is by someone called Catherine Halcom. We've got 60 questions. 35,000 people have had a go at it. Is anything about Catherine there? So wow. 1,436 multiple choice papers. Is there I wonder if there's a way you can search by author on this. If you know, let me know in the block below, in the comments. I don't really know ProProfs quizzes that well and navigation around it, but 6.5 million attempts of these multi choices. Be interesting to see if there's any more CSWIP 3.1s or if it's a range of stuff. So let's have a look at this then. So yeah, thanks Catherine for uploading. Any questions are always good questions because we get to go through them and talk about it. Right, so if I hit start, it's actually a decent photo as well, right? Can I just say, when we use the photographs for quizzes, it's always cool when it's not the same photograph everywhere. And there we go. Just little things in life, isn't it? Right, so I want to start. Right, so I'm reading this. Where are we? In GMA welding, which mode of metal transfer uses the highest and lowest cycles? Highest and lowest cycles. Well, let's have a look at what it is. We've got pulse transfer, dip, globular, and spray. Right, what do they mean by cycles? Looking at the answer, do they mean peak and background current? So dip doesn't use a cycle. It's straight polarity. Spray uses straight polarity. Globular uses straight polarity. So the only one that's different here is pulse. I want to go for that. Oh yes, great. Okay, so the terminology is different, but we get terminology different all around the world. So I would reword this question to say, in GMAW, which mode of metal transfer uses a peak and background current? Something like that, because that's really what we're asking there. Okay, so that's okay. 2. A tensile test was okay. So great. We've got a equation question. We have some videos on equations on the channel. Have a look at them. We've got the heat inputs, and I think it's the 4 or 5 equations to know after heat input. They're older videos. They're one of the first ones we did on the channel. But have a look at them, and they will explain how to do this. Okay, so I think I'm going to need a pen and a piece of paper to try and work this out, and then of course I will try and explain it as we do it. So right, grab a bit of paper, and we'll see where we end up with. Right, so this here is a tensile test. Was 120 millimeters long before testing, and after testing the length was 135 millimeters. What was the percentage elongation? So what this is we've got our tensile sample like this. We clamp it either side, and then we try and pull it apart under our tensile load. Remembering that tensile loading is the ability of a part or an item to withstand this being pulled apart, this tensile loading, right? As it does that, we're going to plot a yield point. Yield point. We're going to plot a tensile graph, which will have its elongation point, which is this straight point, which if we pull it and let go, it'll return back to its size. It will then hit its yield or resistance elastique, its RE position as it goes along. And then it'll start heading back up to the peak of the chart where we get our UTS or our resistance maximum. And then after that point, it starts to heading down and then it fractures and the part comes apart. So that's a standard tensile. Now, so from that, we're getting two bits of information, our yield and our ultimate tensile strength. We need, though, a third part to that, which is elongation. And we get it by measuring the sample before and after testing. So these are done on what we call gauge lengths. So we put 2 marks on the tensile test, which were 120 mil apart. And then when we pull it and we put it back together, the sample, we just lie it back together with the fracture, we remeasure how far the dots are away from each other. So we went from 120 to 135 millimeters. Now, the equation for elongation is elongation, I need to write it down as I'm doing it, equals change in, so the change in length over the original length, right? And then you can do that. That answer is times by 100 to get it into a percentage. So that's what we need to do. We need to do a little bit of maths. Now I'm just wondering if I bring up can we do this on a Excel spreadsheet? Yes, so we've got our Excel spreadsheet here. So our original was 120. Let's zoom in on that. Right. Try and get it in the window, right? So our original, my spelling will be awful on this as I do it live. The original was 120, okay? Our new length is, what did we say, 135, okay? So our equation is elongation percentage is equal to the change in length over the like that, okay? So then if I do that as a little line, and that's our equation in this section here, and we normally show that with a capital A. Okay, so that's our equation. So what we can do is go, well, our percentage elongation is the change in, so we need to know what it's gone up by. So to go from 120 to 135, it's changed by 15 millimeters. So we've got 15 there, and the original was 120. Yeah, so I can just drop a little line in like that. So what we're going to say here is, if it's still on the screen yet, is the percentage elongation equals to 15 divided by 120, so we get 0.125. Now we need to times that by 100, right? So that's going to give us a I'll just drop this down a bit. A percentage increase equals this times 100. It's 12.5%, right? So now we can go back to our answers and see if we've got 12.5% as a potential. Yeah, so A here is 12.5%. So let's give that a go. Great, that's correct. But that's how we go through it. Now, whenever I'm doing any multiple choice like this, I always go through all of the profile. I will write down the initial part on a piece of paper, my scrap bit of paper, my exam, and build it out. I feel it's better to be slow and consistent than to be fast and wrong. Yeah, so let's go from there. Oh, and they even give an explanation of it. That's good. I like it when people do that. Right. Foriated tungsten electrodes have one major disadvantage. So foria is radioactive. It gives off alpha and beta radiation. Occasionally in tests, it's given off gamma radiation as well, but very occasionally. And I've seen test results which show that it's absolutely can be above the action levels for radiation protection. Right, so there's more knowledge and communication around these electrodes, which we've got to be careful about. But they're by far one of the best electrodes, especially for high amperages in TIG, long running conditions. Really, really, really good. There are new electrodes coming to replace them. Things like rare earths. I think Tensile is doing a version called E3, and it's a rare earth mixture. But the problem is they don't tell you what the rare earths are because they're supposedly non-health risk. Therefore, they don't tell you what it is. This is rare earths. We are doing some tests of this in our workshop at the minute to understand how good they are in comparison to foriated electrodes. But radioactive is the thing. Now, when they're in the electrode, it's generally okay. You can touch them. You should limit the amount you touch them, but I'm not personally that worried about it. The problem is when we go to sharpen them into the points for our TIG welding applications, the dust goes in the air. You breathe it in, and once it's in your respiratory tract or your gut, you've bypassed your skin, which is there to protect us from a lot of different forms of radiation, and there is a potential you can increase the risk of cancer. So these nowadays need to be sharpened in self-contained foriated tungsten sharpeners. And then they capture all of the dust, and then you dispose of the dust correctly in line with any of the legal requirements for your location, because it is now radioactive waste, which is going to be challenging for a lot of people. I think there's a cost to get rid of that. So it's use of thick plates, so that's not a disadvantage. Having a lower melting point, it doesn't. It has a higher, so this pure tungsten, and then any of the tungstens which are alloyed, so that whether that be foriated, zirconiated, lanthanum, serrated, they all increase the current carrying capacity. So we've got that. Being very costly. Well, they're all costly, but being radioactive in nature. So that's the one we'll go for. Great. So that's a good question. It's something we should be thinking about nowadays, and going from there. What does the term WPS mean? So, first of all, this should be capital letters, not smaller. So, welding procedure specification. So what we got? Weld procedure specification. That's the one we'll go for. Weld productivity specifications. Weld productivity standard in weld production scheme. Well, that's welding procedure specification. Yeah. I'm not reading out all their justifications for the questions. You should absolutely go and do this test and have a read through and engage with the content as you go through it. You find unacceptable welds and reject them. The welding supervisor insists they are acceptable. He signed them off and requested NDT. What action would you take? Well, it's not for him to sign it off, is it? It's for the welding inspector. And this comes to the whole debate or thing we need to talk about, which is conflict of interests. Welding supervisors run the welders, welding inspectors inspect them. They shouldn't be connected. And I've come across this many times by myself. It's a difficult thing to really deal with. Welding supervisors have a lot of power rightly or wrongly, but they're production driven in the main. And at the end of the day, you shouldn't sign it off if you don't feel it's acceptable. That's the top and bottom of it, really. But if it's gone ahead and been done, what are you going to do? So let's have a look at what we've got. So raise the issue with the quality department supervisor, look at the NDT results, and if they look reasonable, accept them. Well, that's you being forced into making a decision that you weren't making. Nothing, as he's the welding supervisor, I know a great deal about welding. Well, hopefully, but that's not guaranteed. There is no problem as he signed him off, so you're not to blame. Yeah, if he's gone and signed him off and you haven't put your name to it, there is that. You're not to blame. However, you're a quality inspector within the system, and when you know things are going wrong, you should be actioning it in calling foul, really. So I would say, you raise it. You knock it up to your management and say, I'm being overruled here. I don't agree with this. What do you want us to do? That's the better way of dealing with it. Yeah. Which of the following quantitative tests? Which of the following is a quantitative test? So quantitative and qualitative. A quantitative test has a number to it. A qualitative test tends to be our opinion. So when we look at something and have to decide. So a macro, we're going to look at a macro section and see if we can find any defects. Radiography, the same. Bend test, yeah, it bends, but there's no physical measurement from it. We have to look at it and see if it's cracked. So the only one here that gives a measurement is a tensile test. So far, these are good questions. Now, there's 60, in total. This feels at the minute like a good paper. So let's see how we go. When welding medium carbon steel plate over 100mm thickness, would basic electrodes use any pre-treatment before use? Okay, so we've got our free electrodes for MMA. Again, video on MMA on our channel. Go and look at it. CSWIP ask a lot of questions in their exams around MMA. There's a lot of things you can ask, whether that be types of electrodes, how they're controlled, what they're used for, power characteristics, all this type of thing. Okay, so let's reread this question and actually see what the question's asking us. So when welding medium carbon steel plate over 100mm thick, would basic electrodes used any pre-treatment before use? Okay. Not the best worded question, but we're going to say by looking at the answers here, they're saying, look, you're going to use basic electrodes. Do you need to do anything before you use them? Now, because we understand that, we can say the medium carbon steel and the 100mm plate part of this question is noise. It's just there to make a question. The question is, what do we have to do with basic electrodes? So basic electrodes are generally used in engineering, is how I'm terming engineering products. So this is something that requires tensiles and toughness values. We need them to be dry. We normally want them to be low hydrogen. So we would bake them at like 350 degrees, then keep them warm at about 120-ish degrees. Again, manufacturer's recommendations is always the thing to go on there. Until we use them out of quiver, and then away we go. Or we have them in vacuum packs, to which we can use them straight out the vacuum pack. Again, manufacturer's recommendations will say once you open the pack, you get between 10 to 12 hours of use, something like that. Okay, so that's really what we're looking for in basic electrodes. Okay, so we have none if they were sealed in a vacuum pack and used straight away. Baked at 150 degrees for 4 hours prior to use, None if they were vacuum packed open 8 hours prior to use in heat over 500 degrees. Right, so I'm going to get rid of 500 degrees because that's just way too hot. That's really hot. Baked at 150, well, you don't bake at 150. It needs to be like 300 plus to bake, so we can get rid of that one. So it gives us two similar ones here, A and C, or the equivalent of A and C here. None if they were sealed in a vacuum pack immediately before use, and none if they were in a vacuum pack opened 8 hours. Now, my gut feel is I'm going to go with 8 hours because you don't have to open them immediately, right? You would only be able to use one electrode out of the pack if that was the case. So I'm going to go with none with that. Okay. I don't know if I fully agree with that. I think I don't mind being wrong. But the wording there for me is I literally would have to open a pack every time I use it, get one electrode out, because to use the next electrode wouldn't be opened immediately. But yeah, I would like to think the answer is 8 hours before use, and then I don't have to do anything. That would be more thing. Yeah. In the submerged arc welding process, before starting the weld, you observe that the WPS was made with agglomerated flux, but they would now like to use fused flux. The classification for both is the same, though both have been tested under different parameters and conditions. In such you will. That's an interesting one. Can agglomerated and fused flux be under the same designation? I'm not sure. I'd have to see, but that's I'll be questioning that one for my own sanity, just to have a look. But they're saying they are the same. Yeah, both under the same. Sorry. The classification of both are the same. There you go. Yeah. Right. Inform the manager when you have time. Well, that's just never going to be a right answer, is it? Try to qualify the process with a new WPS. Permit the welding to proceed since the classification is the same. Insist on using the same type approved in WPS. Well, in general, if you're outside of what your WPS says to do, you shouldn't be doing it. Because as inspectors, we shouldn't be making that call. That should be given to a welding engineer to do. So my answer is going to be, well, if it's not the same as what's in the WPS, then the WPS needs changing. So we'll go with that. Cool. So, right, got that right. Which one of these elongation values would be more susceptible to laminar tearing? Now, I like this type of question. So, our normal statement is anything that has a ductility of less, or a straw test ductility, short transverse reduction in area, less than 20% is a problem. Okay, and then it stages down in about 5% values. So we want better than 20%. In most carbon steels, if you look at a mill cert, you'll see that it actually gets better than 35%. So that's okay. Hydrogen cracking is considered a cold crack as it will not form until the weldment cool to below. Right, so if we get hydrogen into our welds, hydrogen gets mixed up, it's there. As the material cools, right, when we get below 300 degrees Celsius, the material gets to a point where that hydrogen can no longer diffuse and escape. So it's 300 degrees Celsius. During inspection of a fillet weld, you notice slag in toes of the weld. What action will you take? Okay, so let's have a look. Have the welder remove the slag as it could mask a discontinuity. Okay, that seems fair. Tell the welder to leave the slag as it will add strength to the fillet weld. No. That's an interesting way of looking at it, but no. Measure the slag if it's less than 3 millimeters. Well, that depends on the acceptance criteria we're using. As the fillet weld does not need to be strong, the slag is not a problem, right? So out of these, the best answer is A. Have the welder remove it, because it may be hiding something underneath. Yeah. There should be no reason why a welder is submitting welds to be inspected if they've still got slag on it. In weld inspection, what does the term WPS typically refer to? Also, it's similar to the last one we had. So WPS written in capital letters this time. That's what we like. Welding procedure specifications. So that is this one. Right. It is always necessary to preheat the base metal before welding. Well, it's not. Is it? If it's only in accordance with WPS, okay, that seems fair. If using cellulosic electrodes to provide enough heat for what? If the equipment is available, it must be used, not on a sunny day. Again, as inspectors, I would say we just follow the WPS, right? Now, in reality, not all materials need to be preheated. I would generally say it depends on the type of carbon steel we're using. You know, stainless steel doesn't get preheated, doesn't have enough carbon to have a hardness susceptibility. But carbon steels, the higher the CEV, the more likely it is to have a higher hardness value after welding. So CEV, carbon equivalent value, as that increases, the risk of martensitic formations is increased. Have a look at our video on time temperature transformation graphs. So I'm going to say it in accordance with WPS. Follow that and we'll be all right. You can always blame the welding engineer if it goes wrong. Everybody else does. So why not jump on it? Right. Which test from below measures the material property known as fracture toughness? Okay, so you are very unlikely to go into any detail about this type of test within your CSWIP course. Okay, you will talk about sharp impact tests, which look at toughness, but here we have a certain type of toughness, which is called fracture toughness. Now, a lot of people, when they hear the word fracture toughness, are instantly drawn to a fillet weld fracture test. It's not that. What it is a CTOD test, a crack tip open displacement test. And this is a very expensive test. So a toughness, a sharp impact toughness, is going to cost you in the UK at the minute somewhere between £80 to £120 a set of three. A CTOD is something like £2,500 a test. They're machined blocks which have a fatigue crack put into them, and then we break them to understand the fracture toughness. Fracture toughness is then used for design in-depth designs to understand material properties and their effect on how stuff fails. Okay, so it's CTODs. Right. What cause of action should be taken upon finding a welder using incorrect welding consumables? Comments below what you should do to welders who are using the incorrect consumables. They're not reading the WPSs. This is the thing, isn't it? Right. So if you're outside the WPS, what do you do? Comment below. Come on, let's get the engagement on these videos up a little bit. Right. So report the incident and record the relevant information. Allow the welding to proceed if the workmanship is good. Change the electrode for the current type and continue welding. That's weird. None if the tensile strength of the consumable is the same as approved. So it's a failure investigation, isn't it? Report the incident and record the relevant information. Who, what, when, where. That's got to be the answer there. It has to be. Yeah. I remember, a side story, when I was an apprentice, I worked for a company who did a lot of aerospace components, and I was given some stainless steel components to make. They're basically engine covers for fighter planes, which was really cool to do when you're like 17 year old. And because I was a kid, I wasn't paying attention, I ended up welding all of these with titanium wire. Now, it went together, but as soon as you tried to bend it, it just broke, yeah? So just because something looks all right doesn't mean it is. And we need to remember that. Think of James, who is stupid and uses the wrong electrodes. But there's a reason why we have a material and an electrode that go together, or a filler wire and a material type that go together. It's because everything's got to work right to give the right mechanical properties across that joint. And we've proven through a welding qualification that they go together and it does what we expect it to do. Yeah. 17. For a bend test, which of the following is not true? Again, with all of these types of questions, we need to read the question and say, not true. Okay. It given indication of ductility of the weld. It gives, right, sorry. It gives indication of ductility, right. So does a bend test give an indication of ductility? Yes and no. But it's a qualitative measure of ductility, that if you can bend something around 180 degrees and it doesn't crack, yeah, it kind of goes. But I don't like it as a measurement, you know, for all my opinion matters. A 4T bend is more severe than a 2T bend. Well, no, because 4 times thickness is bigger than a 2 times thickness bend, so 4T is actually less severe. The outer surface of the bend specimen is examined. Well, kind of pretty much the whole is done. So you are not just doing the outer surface, you're doing down to center line, really. Again, am I being reading into it too much? It reveals defects like lack of fusion and porosity. If the sample was to fail, yes, but it's not the purpose of the test. We're going to get rid of B. That's definitely not right. I'm trying to guess how people will try and answer this question as well, right? I'm going to say it gives an indication of the ductility. How is a 4 times thickness bend more severe than a 2T bend? Can anybody explain that to me? If I'm reading this question wrong, please give me a shout, comments below, and then we'll see how it is. But a 4T bend is not more severe than a 2T bend. In fact, the opposite true. A bend test refers to the thickness of the sample, so a 2T bend means which of these tests is not true? There you go. There's proof of doing a question after I said read the question and go for it. I've just answered it as which one is true. It gives an indication of ductility. And if I had read it properly, hands up, I got that one wrong. Here you go. Come on, James. Pay attention. I'm going to leave this in on purpose so you can see that we all make mistakes. A typical temperature for stress relieving carbon steel is. Stress relieving occurs at 600 degrees. Good temperatures for us to know. 600 degrees for stress relieving, 900 degrees for annealing and normalizing, 1200 for solution heat treat, done on stainless steels to correct weld decay. They're kind of like the 4 main temperatures. It's good to know. And if you know 4, then hopefully you can pin down any other ones you get out of that, right? A weld all around symbol is not required when indicating a nozzle weld to a shell, indicating a circumferential weld. All of the answers indicating a pipe. Does that mean like all of the above? Is that what that means? It should be all of the above. Yeah. So if you've got a butt joint that goes all the way around something, so a circumferential weld, a pipe to a pipe butt weld is like a circumferential weld, isn't it? Indicating a nozzle to a shell, so a nozzle coming in and going all the way around that. They don't need all the way around because they're just one joint. We will use terms like all the way around. Let's say when you have a plate to a plate and you can actually come round the edge. So you weld down one side, across the thickness, and then back down and across the thickness. Because they're technically four different positions to weld at. So welding all the way around catches it like that. Okay, this video is getting long. It's 40 minutes now, so this is going to be a last question. And then I'll do the rest in a follow-up video. Okay, which of the following helps to reduce distortion? Using a minimum number of runs, welding with a manual method, using a very high heat input, or using a maximum number of runs. So so in a single V joint, as we weld, what happens is the weld metal is there and a contraction shrinks and it pulls the part up. And then if we put another run in, it'll pull it up again and pull it up again and pull it up again. So the more run passes we have, the more distortion we have. Okay? But the more runs we have, the greater the grain refinement. So it's a lot of the time, it's better to have more runs because you get better final mechanical properties. But you'll get more distortion. So then we have to clamp. But if we clamp, we're going to get more residual stress because we have less distortion. But this question is just saying, when we're only concentrating on distortion, what's the best way of doing that? Well, that's to reduce the amount of contraction phases we have. So that's going to use a minimum number of runs. Now, I think you'll be right in asking the question, but not if I've got, say, 10 mil thick plate and I do 5 runs, I'm going to get like 5 contraction and distortion in that. But if I do one big run, surely I'm just going to get one huge amount of distortion. And I can understand why you would kind of think that, but that's just not how it works. Small but more often is more than one not very big movement. Okay, so we've got to keep it like that. Yeah, right. That we're up to question 20 of 60. I'm doing this live, kind of going through it. I'm not trying to. Well, I'm not at all editing anything out. So you're getting my thought process as I go through questions that I've never seen. Hopefully that is of interest. If you want to laugh at me for getting stupid questions wrong and not reading the questions, please do below. Hopefully you see we all read questions wrong. We've just got to kind of try not to do that in tests. A lot of the time I've seen clients, students who have gone, I just didn't read that question and I got it wrong. It's like, yeah, drop the mark. It doesn't take many marks to drop before we fail an exam. So we've got to be careful with that. So with that one then, I will see you in the next one where we'll continue. We'll probably do questions 20 to 40. In the meantime, I tell you what, I'm going to drop in the link to this question paper below. It's always good. People take time to upload these onto places like ProProfs and that, which show their support to them. Go and do the test, make any notes, and then hopefully when we're going through these questions, if you've got any questions, we'll answer them here. If not, you can drop in your question against an individual question below. Please do that for questions 1 to 20. If there's anything you don't feel I've covered in enough detail for you, just say question number, what your question is, and then I'll come back to it and do that. Engagement on the channel really helps. Honestly, when I get videos with lots of likes or lots of comments, the view rate goes through the roof because the algorithm sees it and passes it out more. So please do that. If you've made it this far, hit like. And if you're not subscribed, 60% of people are returning viewers and don't subscribe. It does help us a lot. It just lets us know that people want to see our content, and it's nice to know that sometimes, you know. So with that, then I'll see you in the next one, and good luck with your studies.